Hello dear students, welcome you all for transmission and distribution class. So in the previous class, we have seen the capacitance grading of the cable. Now we will see the intersheath grading. So in this method of cable grading, a homogeneous dielectric is used, but it is divided into various layers by placing metallic intersheath between the core and lead sheath. The intersheaths are held at suitable potentials which are in between the core potential and the earth potential. So this arrangement improves the voltage distribution in the dielectric of the cable and consequently more uniform potential gradient obtained. So we see in the figure 11.17, consider a cable with a core diameter of small d and outer diameter, that is outer sheath diameter is capital D. Suppose two intersheaths of diameter d1 and d2, that is small d1 and small d2, are inserted into a homogeneous dielectric, are maintained at some fixed potential. Let V1, V2, V3 are the respectively voltage between the core and intersheath 1, between intersheath 1 and 2, between intersheath 2 and outer sheath. Okay. As there is a definite potential difference in the inner and outer layer of the each intersheath, therefore, each sheath can be treated like a homogeneous single core cable. So, maximum stress between the core and intersheath is given by G1 max is equal to V1 by D by 2 natural logarithm of D1 by D. Same thing for G2 max is equal to what? V2 by D1 by 2 into natural logarithm of D2 by D1, and the G max of 3 G3 max is given by V3 by D2 by 2 into log natural of D capital D by D2. Since the dielectric is homogeneous, the maximum stress in each layer is same. So all this G1 max is equal to G2 max is equal to G3 max equal to G max. So all these equations are equal. Now as the cable behaves like a three capacitors in series, therefore all the potential in phase voltage are voltage conductor and earth lead sheath is given by V is equal to V1 plus V2 plus V3. Here intersheath grading has three principal disadvantages. Firstly, there are complication in fixing these potentials. Secondly, intersheaths are likely to damage during the transportation and installation. It may result in the local concentration of potential gradient. And thirdly, there are considerable loss in the intersheath due to the charging current. For these reasons, intersheath grading is rarely used. So anyhow, it has got advantages, but some practical difficulties are there in this intersheath grading. So it is used very rarely because intersheath whatever we are inserting the layers, that may get damaged due to transport or due well making it in fixed installing it, we are facing some problems. Okay, we'll see one or two problems here so as to complete the intersheath grading. The problem is given as a single core cable of conductor diameter 2 centimeter and lead sheath of diameter 5.3 centimeter to be used on a 66 kV 3-phase system. Two intersheaths of diameter 3.1 centimeter and 4.2 centimeters are introduced between core and lead sheath. If the maximum stress in the layers is same, find the voltage on the intersheath. So we need to know what are the things given. Anyhow, the diameter of the cable is given, that is D is equal to 2 centimeter. And intersheath 2 they are given with value D1 is equal to 3.1 centimeter and D2 is equal to 4.2 centimeter. And now capital D is also given here 5.2 centimeter. Voltage is given as 66 kV and it is given as three-phase system. So we need to know the maximum voltage. That our value as 66 kV is RMS line voltage. By converting it to phase voltage is 66 by root 3, multiplying by root 2 to get the maximum voltage. So we are getting the maximum voltage of 53.9 kV. What is the equation of G1 max? We know V1 by D by 2 into natural logarithm of D1 by D. By putting these values, we don't know what is the value exactly V1. So just put the V1 as it is. I will get the 2.28 V1. Now G2 max we need to find out. So the same, our equations we know V2 by D1 by 2 into natural logarithm of D2 by D1. Putting the values, we don't know the value of V2, keep V2 as it is. That is, we will get 2.12 V2. Same thing for G3, we will get 2.04 of V3. So we don't know what is the value of V1, V2, V3. But we know that in intersect grading, G1 max is equal to G2 max is equal to G3 max. So here we can equate this 2.28 V1 is equal to 2.12 V2 is equal to 2.04 V3. So take two things. I can put the value of V2 in terms of V1 and and also I can put the V3 in terms of V1. So we know that V is equal to V1 plus V2 plus V3, and I will get all the V2 and V3 in terms of V1. So I will get the value is 53.9, that is maximum V is equal to 3.192 V1, or V1 is nothing but 16.8 kV. So once we know the V1, we can find out V2 and V3 using the the simplifications we have done. Voltage on the first intersheath is given by the 37.02 kV, and voltage on second intersheath is given by 18.88 kV. This is very easiest problem you can solve by your own, because here we are knowing that G1 max, G2 max, G3 max are same. So using equating that one, we will get the result. So we will see one more problem here. A single core 6 kV cable working on three-phase system has a conductor diameter of 2 cm and a sheath of inside diameter 5.3 cm. If two intersheaths are introduced in such a way that stress varies between the same maximum and minimum in the three layers. Find number one, the position of intersheath. Second one is voltage on the intersheath, and maximum and minimum stresses. So the given things are here, small d, capital D, and V is given. V means 60 kV RMS value given. We are converting it to phase and multiplying the root 2 to get the maximum value. So the first thing is position of the intersheath. We need to calculate what is G1, D2. So we know that G1 max, G2 max, G3 max equations we are knowing very well, and we know that all these three things are equal. So in order that the stress may vary between the same maximum and minimum in three layers, we will have d1 by d is equal to d2 by d is equal to d by d2. So, or we can write the v1 by d is equal to v2 by d1 is equal to v3 by d2. So this is what the conclusion we should have, because here how the if you compare all these three equations, we can conclude that we can write like this. Okay. So from this equation, d1 square is equal to d into d2, which is equal to 2d2. Is it? So d2 is equal to d1 square by 2, or d1 d2 is equal to capital D into d, which is equal to 10.6 centimeters. So if you go for solving the d1 and d2, we'll get d1 is equal to 2.76 centimeter and d2 is equal to 3.8 centimeter. So the intersheaths are of diameter 2.76 centimeter, and another second intersheath is at 3.8 centimeter. Now voltage, we know that V is equal to V1 plus V2 plus V3, or we know the value of V, and instead of V2 we will put the d1 by d V1, instead of V3 we will put d2 by d V1. So all the terms we will write it in terms of V1. So we will get the value of V1, that is 12.6 kV. Once we find the V1, we can find out the V2 and V3. So stress in the dielectric, that is maximum and minimum stress. So we will get the equations here. That maximum stress is nothing but V1 by d by 2 natural logarithm of d1 by d, which is 39 kV per centimeter, and minimum stress is V1 by d1 by 2 here, because maximum stress is at the conductor side and minimum stress is at the other end. So the here d and d1 is used here. So the minimum stress is getting by 28.35 kV per centimeter. So this is regarding the intersheath grading. So two different types of gradings we are seeing. One is capacitance grading, another one is intersheath grading. Intersheath grading is used rarely because of some practical difficulties. Okay, in the next class we will see the how a capacitance of a three-core cable is measured, and what are other things, and some of the things are left, that is charging current and all. We will see those things in the next class. If you find any difficulties, you can contact me. Thank you.